The most distant human-made object ever sent into space is NASA's Voyager 1 spacecraft. A lone traveler beyond the known worlds, Voyager 1 has crossed into interstellar space, a place no spacecraft had ever reached before. It's almost unimaginable. A probe launched more than 45 years ago is still sending back data from a region of space so remote, it's practically science fiction. And yet, it's real. This spacecraft, born in the analog era of rotary phones and cassette tapes, continues to rewrite the history of space exploration. Even more incredible is that Voyager 1 communicates with Earth using technology that predates the first home computer. It's not just far away, it's astonishingly functional. And just recently, this resilient little explorer made a discovery that sent shockwaves through the scientific community. A finding so strange, so unexpected, that it has once again drawn global attention to a machine that was never supposed to last this long. To understand the magnitude of this achievement, we have to go back to a unique turning point in history. In the late 1960s, a brilliant mind at NASA's Jet Propulsion Laboratory, Gary Flandreau, made a remarkable calculation. Using only a pencil and paper, no supercomputers, no simulation software, Flandreau discovered that the outer planets would soon align in a rare cosmic pattern. This planetary configuration, happening just once every 176 years, would allow a spacecraft to slingshot from one planet to the next using their gravity, gaining momentum like a celestial relay race. It was a once-in-a-lifetime opportunity. Normally, a mission from Earth to Neptune might take 30 years. But with this alignment, it could be done in just 12. NASA didn't hesitate. In 1977, within just 15 days of each other, Voyager 1 and its twin, Voyager 2, were launched into the void. Their goal? To take advantage of this cosmic window, explore the outer planets, and then fade into silence. No one expected what came next. These twin spacecraft weren't just successful, they were revolutionary. Voyager 1 and 2 sent back the first close-up images of Jupiter and Saturn and unveiled their moons as complex, dynamic worlds. We saw erupting volcanoes on Io, shimmering ice on Europa, and mysterious rings encircling Saturn. Voyager 2 would go even further, becoming the first and only spacecraft to fly past Uranus in 1986, and Neptune in 1989. There, it discovered supersonic winds, strange magnetic fields, and icy, unknown moons. These weren't just flybys, they were glimpses into entire alien systems. Even today, these spacecraft are still out there, Voyager 1 more than 14.8 billion miles from Earth. That's over 159 times the distance between the Earth and the Sun. And yet, they continue to operate, powered by small nuclear generators and computers with just 69 kilobytes of memory. To put that in perspective, a single photo on your phone could be 100 times larger. The data they collect is stored on 8-track tape recorders and transmitted through an antenna using only 23 watts, barely enough to power a refrigerator light bulb. Communicating with Earth now takes over 21 hours one way. Each day, the signal gets fainter. And yet, NASA's Deep Space Network still picks up these whispers from the edge of the solar system, filtering them from the growing sea of background noise produced by our increasingly noisy planet. But the greatest leap came in 2012, when Voyager 1 crossed a mysterious boundary known as the heliopause, the point where the solar wind, which originates from our Sun, gives way to the winds of interstellar space. For decades, scientists believed that crossing this line would produce a sudden change in the environment, a spike in cosmic rays, a shift in magnetic fields. But when Voyager 1 crossed into this unknown region on August 25, 2012, it didn't behave as expected. The probe detected a dramatic increase in plasma density, but the magnetic field remained largely unchanged. That left scientists puzzled. Was the boundary more complex than we thought? Was interstellar space blending with the outer edge of our solar system in ways we hadn't predicted? Voyager 1 had revealed something fundamental. The transition into interstellar space wasn't a clean line, it was a zone, a turbulent buffer where solar influence fades and the realm of the stars begins. This finding challenged decades of theory and continues to fuel debate among astrophysicists today. What lies beyond is the Oort cloud, a vast sphere of icy bodies surrounding our solar system like a ghostly halo. Voyager 1 won't reach that region for another 300 years, and it will take 30,000 years to pass through it completely. But it's still heading there, slowly drifting into the galaxy, carrying with it a golden record, a message in a bottle for any intelligent life that may one day find it. That record, created by Carl Sagan and his team, contains music, greetings, and images of Earth. It's humanity's attempt to say, "We were here. This is who we were." And it's still traveling, outlasting presidents, borders, wars, and even the technologies that built it. The Voyagers are no longer just spacecraft. They are emissaries, silent ambassadors of a curious species. Their endurance is a testament to human ingenuity and the drive to explore the unknown. Let us know your thoughts in the comments below. If you enjoyed this journey through time and space, don't forget to like the video and subscribe for more stories that explore the outer edges of science and discovery.